Welcome back to the channel. I forgot to do a beginning to this video, so I'm just sat at home before I head to work and I just thought I'd add it here. This is a video showing how quick or how long it takes to grind a Chevy V8 crankshaft. There's some footage after the crankshaft grind of another V8 engine that I built. The footage was on an old GoPro, so I've added that. That's it. Hope you enjoy the video. If you could hit the subscribe button, please, that'd be great. Hope you enjoy. So I'm just about ready to start grinding this small block Chevy crank. It's already at 1010. When it's been ground in the past, they haven't put much of a radius on it, so I've dressed my stone with a bigger radius, and hopefully taking 10 thou off, we should be able to replace some of the original radius with a bit of luck. And the same customer dropped off this big block Ford crank, which I've polished. He didn't want that grinding, so that was just in for a polish. So let's get the grinder up and running and see how long it takes to grind it from start to finish. I'm going to get the tripod for the camera first. It's 20 to 6, so let's say it's 5:45 by the time I've got the tripod. I'm going to get a spare battery for the GoPro and we'll time lapse the whole crank getting ground. So when grinding the big ends, this needs a bit of patience really. I feed the wheel in by half a thou at a time on a downward cut. That's just something that I do, force of habit, but I just do it that way because I don't like to see the crank try and burn or chatter, which we don't really suffer with any problems with that. So with the big ends, I just take my time, just keep going, keep checking, because I want it bang on the top tolerance. So then when I do polish it, I know that I'm going to be kind of right in the middle of where I want to be. If I've got a customer that wants to be in a specific area in the tolerance, or if I'm building an engine and I want to be at the top tolerance or the bottom tolerance, I can adjust it to suit that. If you're enjoying this content, I mean, we do this all the time, show exactly how things work. If you're enjoying it, if you could really do us a favour, it costs nothing to do it, but if you could hit the subscribe button, and then if you want to see an alert when we post a video, just hit the little bell at the bottom as well, and then you'll get alerts every time we post a video. It means a lot to us, it helps us keep the channel going, and like I say, it's free to you guys as well, so if you could hit the subscribe button, it would be really appreciated. The big ends are now done, all 8 of them. I've ground them to top tolerance, and that way I'll polish a couple of tenths off it, so it'll be just below top tolerance. The nice big radius I've put on my wheel hasn't cleaned up the radius that someone else has ground onto it before, so it is still quite sharp in there. There's a slight radius on there, but not what I'd normally like to run. My bit has radiused into that though, so it's definitely a lot stronger than what it was. What I've got to do now is change the machine from the big end side to the main side of the machine. So to do that, the first thing we need to do is to make the crank turn faster. That's done by just moving this gearbox lever here. You have to have the crank turn, and then I'll just knock this lever over so it puts it into a faster gear. We then need to move it away from these fingers, so that locks in there and stays. We then bring this attachment in, which is for the mains. So we do that just by bringing that forward, and that locks that in. I always start on the centre main, so we'll line that up first. And then this here is called a continuous gauge, or an Arnold gauge. And what that does is we can set this to 10 or however much wears in there, and this will keep an eye on the crank as we're grinding it down. So the first thing we need to do is just loosen off these Allen keys and adjust it so it's set for doing these bigger journal cranks. And I'll just nip that up once just to see. Might need a bit more yet. No, that's fine. So I can nip this up now nice and tight. And then what I'll do is I'll actually set this properly once I've started to grind the crank. So what I'm going to do first of all is set it so it's big by, say, 10 thou. Take the suds guard off. And then I want to bring the wheel closer to the main till it locks in. Feed the wheel in. Keeping an eye that I'm in the centre of the journal. And then I want to do it where I can just see some light between the stone and the crank, just in case there is any distortion in the crank, we can correct that. Then we'll put the suds guard back on. And then feed this wheel in until we start to grind. In fact, I need to put the fingers on for the suds. This redirects the coolant further down the wheel. And then what I'm looking for is that nice clean bit appearing on the crank. So that's the crank starting to grind. What I'll do is I'll show you that, and then I'm going to put you onto time lapse. So you can just see the nice shiny bit starting to appear. You can actually see the wear in the crank. That's what I'm looking at. It's worn there. Well, there we go. Grinding the mains is a lot quicker than grinding the big ends, although it's just as important. I keep checking the size with the Arnold gauge and with the micrometer. I don't want to go below. I don't want to grind too much off it. The difference between top and bottom tolerance on most cranks is about 5 to 7/10 of a thou. So it's really important to just keep checking. I don't want it big. I don't want it small. We're polishing it now. So after I've polished it, I will then go back and check all my tolerances to make sure it's bang on. Right, so that's the Chevy all ground. It was already at 1010, so I've ground it to plus 20 on the mains, plus 20 on the big ends. I've managed to get into the radius on the mains and tidy those up. I've polished all the crank as well. I've checked it, measured it, it's all good, so I'm going to cover it in spray grease now. And the time is, the time is 7 o'clock, so it's taken an hour and 15 minutes from running it up in the crank grinder to fully grinding it. It's ready to lift out now. So thanks for watching this video, guys. I think what I'm going to do is I've got some old footage on another GoPro or on my old iPad, and I'm going to add that to the end of this video. It's another Chevy. It's got nothing to do with this engine. It's another Chevy 350 that I built for a customer, but there was some footage missing. So there's the block being bored, the crank being ground, and the bottom end being assembled, but I think there's a couple of bits missing, but I'm going to add it to the end of this video. Take care, guys, and see you later. Ta-ra. So a couple of months ago, a couple of weeks ago actually, Sam got me a present from America, and I'll open it and show you what it is. It was videoed on TikTok live, and it's Jesse off the first Fast and the Furious, whose real name is Chad, and he was doing signed pictures. So Sam got me that, so thank you very much, Sam. That's really cool. It says there's something about engines that calms me down. How cool is that? So the first job in for me is, machining wise, is a 350 Chevy, small block Chevy. It's been here for a few weeks. So that's the block, the crank, pistons and rods that my customer's dropped off. And then he's bought some Keith Black pistons for it, which are down here. So what I'm going to do is set up the boring bar stand, try and plot the perfect centre of the bore on the 350 off the crank main housing, and start to rebore it and prep it and machine it ready for building. We've got to build the small end up for the short motor up for the customer as well. So a bit different. Quite enjoyed doing the American stuff. It's just a bit heavy, but in the new place we're going to be a bit more kitted for that, because we'll have overhead A-frame gantry to move it about. But at the minute it's just elbow grease to move it. So I've got the block here. I'm going to get that debunged. I'm going to take all the gallery bungs out of this, the core plugs. I'm going to get that in the acid for the day to clean it up, and then it needs reboring. The crankshaft's been in the acid, so what I'm going to do now is get this sitting level in the crank grinder, dress the wheel on the crank grinder, check the radius in the corners here, measure it, see where we're at crankshaft size wise, and then regrind that. So on the 350 Chevy, that's the first big end done. I've got that down to size, so I'm going to move on to the next one now. So I'm just grinding this down so it's about a thou away from the final size. What I'm going to do now is back the fingers off so it moves the cutting wheel away from the crankshaft. Like in previous videos, I've moved this one complete revolution back so I know where I'm starting from. Switch the machine off, and then I'll lift the wheel off. I'll have a measure up, know how much I've got to get from a final cut, and then yeah, take it off basically. In fact, let me leave that on. I'll see if I can balance that. So I've been and made sure that my micrometer is set perfectly with my 2 setting bars. I set it with the 2-inch setting bar and the 3-inch setting bar, and then make sure that the zeros line up both ends, and then I know that the micrometer is good. And then just very delicately, put some pressure on the mic and take a reading. So that wants 1.5 thousandths of an inch off it to get it to size. Check in the middle. Yeah, exactly 1.5 thou. So what's nice is also the cutting wheel is cutting perfectly parallel across the crankshaft journal. So now very carefully put the fingers onto the crankshaft, start the machine up, one complete turn around here, and then what I'm going to do is I'm going to take 1/1000th of an inch or 1.5 thousandths of an inch off the crank, and then I'm going to let the crank rotate about 4 or 5 times and then traverse the crank over to the left hand side. Make sure getting both radiuses nice, because I've put a nice radius on the wheel, and then that'll be journal number 2 done. So I'm going to start moving the crank now to the left, ever so slowly. I don't want to burn the end of the, I don't want to burn the journal of the crank on the end of the wheel, which if you move it too fast can happen. And then what you'll see is, if a crank's ever been ground bad, it looks like a 50p piece, and that's where the wheel's out of balance. And if you can see real strong burn marks in it, it's where they've either cut in too deep or tried to rush the job along and traverse the crank over one way too fast. So I'm in no rush, I'm just letting the wheel do its job. I absolutely love this crank grinder. I could grind cranks all day. It's so mesmerising watching the crank come back into shape, especially if it's a crank that looks okay but is actually quite badly distorted. When you see it start to take shape again, it's awesome. I'm about halfway over the journal of the crank now. And then what you'll hear in a minute is the radius of the wheel just start to bite into the radius of the crankshaft. So what I'll do is I'll let it touch the radius and then just ever so slightly back it away. Must be about there now. It actually sounds worse than what it is. I'm very, very delicately touching that. So now I'm going to let it have a couple of passes, and then I'll back the wheel off and we'll have another measure up. absolutely spot on. I like that. So there we go. I mean, it don't get much better than that for a ground finish. I mean, it will get polished as well, but like I say, taking your time, letting the wheel do its work, and even moving across that big wide journal, the actual finish result is awesome. So there's 2 more big ends to do on that, which I'll crack on and do, and then it's on to the mains. So I'm back working on the small block Chevy. I've had that shelved for a couple of weeks actually. Well, I've been doing other bits and bobs, but my customer popped in and he's needing it, so I've got it back off the shelf to get on with it. And I thought I'll just show you what I'm doing. It's all been in the acid. I've got to take the core plugs out, prep all the block because I've got to build it as a short assembly. Now to bore these, they're a bit tricky with the boring bar because the boring bar bolts to the block face and machines parallel from the block face, so they're a bit tricky to hold. Now I don't do many V8s, so I've never really needed until recently a proper boring machine. I have bought a boring machine which is getting delivered on the 10th, and I'm also trying to buy a second boring machine, slightly newer than the one that I've got coming. Then that comes with a proper V8 rollover jig, and I'm not going to say the job would be better because I'm going to make sure this one's bored perfectly anyway, but it will definitely be quicker. Now what I did to make the odd V8 that I do easier to bore is I just quickly made this cradle which I bolt to the front, and then this just slides in, and I've got it drilled for some different V8 settings. I can just nip this up, and then what this does is it just allows the block to sit straight when I'm boring it, and when it goes into honing I can hone it a bit better as well because I've got something to clamp against, where normally I'm trying to use bits of wood and all sorts of stuff, which isn't brilliant. So as crude as this looks, and I apologise for it, it does work a treat. So before I can bore it, I need to be able to get the boring bar onto the block surface, and I also need to make sure that the block surface is really clean, nice and flat. And these dowels here, these are a little sod to get out. Normally you wreck them getting them out, but basically what I've got is this dowel puller. So we find the collet that fits it, push it on to the top of the dowel, and then put the slide hammer on, put the collar over the slide hammer, and then make sure you get a real good bang on there to lock the collet onto the dowel, and then just keep tapping up, and there we are. And then to release it, we just slide this collar over there, slide hammer down, and that releases the collet, and then we could just basically just get that out. It is turning, but I could just push it from the back and just find something. But there we are, that's out now. So I've already moved this side and I've got the other bank to do, but I'm going to concentrate on this side first. So the next thing now is to clean this up so we get a good clamp with the boring bar onto the block face. So that's the boring bar now mounted onto the block face. It's all anchored down. The next thing I need to do is set up the cutting tool. So to do that, what I'm going to do quickly is just dress the cutting edge. So it's a 3-step process. First you use the machine to dress it. First of all you use one of these outers, then the second one of these outers, and then you finish off by just dressing the actual cutting blade. And then that is at the top of the bar here. So it has a diamond wheel up here. So basically we switch the machine on. And then just very carefully come down and clean up the first edge. and the second, and then finish it off with the cutting edge. So the next thing I'm going to do is measure the 8 pistons, and the reason that I'm going to measure all 8 is because I want to know that they're all sized perfectly in case I need to adjust the bores with the honer, and then because every piston will be marked per cylinder, if I do need to adjust the bores I can do. These are hypereutectic pistons, which basically means they can run a tighter clearance. They're softer than softer than a forged piston, so these will do miles and miles and miles, where a forged piston, they're very strong and they can take extreme conditions as in racing or boost applications, but they're not really designed for 100,000 miles. So what's good about these are Keith Black pistons, and they've got on this moly coating here, this anti-slip coating, there's a little dot here and a little dot there. That's basically so we can measure it with the micrometer. So we could just line the micrometer up with them holes and then basically take a reading. So what I'm going to do is go through all 8 of them. I'll make a note in my notebook, see what the piston manufacturer recommends the piston to bore clearance to be, and that's what we're running this, because this is going in a Chevy pickup truck, so it's not high performance by any stretch of the imagination. It wants to be nice and quiet and run properly. So I'm going to measure all 8 of them. I'll make my notes, mark them all up, and yeah, and crack on with the rebore. So the Chevy's all washed and bored. We've got the core plugs out of it and whatnot, so Sam's now just giving it some primer and then getting ready to give it its final coat in black. So on the small block Chevy, it's now been through the wash. I've had these bungs out and used I'll show you, a brush on a flexible stick, one of these, to clean it all out. So it's all good in there. I've then fitted these new core plugs. Well, these are core plugs and this is a camshaft plug. So the cam runs in this way, and then that's a plug for the back of the engine. So they're sealed in. I'm now going to bolt the stand on, or bolt the back plate of the stand on, I should say, and get it on a stand and then just assemble it. So I'm getting the small block Chevy engine finished today, and I've cleaned all the caps, cleaned all the bearings. I'm just putting the rear main on, just putting a tiny little bit of silicone just here, just to make sure that it doesn't leak. So I'm going to torque these down to 75 foot-pound. Once it's torqued down, and I'm going to check my end float, then spin it over and fit the pistons and rods. So that's the mains now all torqued up. I've checked the end float and it's coming in at 2.5 thou. The recommended end float for this engine is between 2 and 7 thou. So we're bang on with that. And I've ground the crankshaft, checked the main housings, and with it torqued up, I mean, you can turn it really nice with just one finger. So I'm really happy with that. I'm going to turn the engine over now and fit the pistons and rods, torque it up, and then this bottom end's all built. So the next thing I'm going to do is gap the piston rings. So we're going to take them out of the box. Look at what piston ring gap that they want us to set it to. It's normally a factor of the finished bore size. It's in Spanish, I can't read that. Yeah, so check the ring clearance near the bottom of the ring travel. So it's 3 to 4 thou per inch of bore, so it's quite an easy one to work out. Now, the top ring and the second ring are two different materials. The top ring on these is a chrome ring. These are actually quite strong. You can't, these have a job to snap, they bend, which obviously we don't want to do that, but and these are also they're also a directional ring, so it always says on them top, so that sits against the top of the crown of the piston basically, and then it has this bevel on the back which helps the compression push the ring onto the bore, and then it's like a barrel edged ring as well. The second rings are ductile material, so these are very brittle, these break very easy. Once again, they're marked with top because they have a scraper here. So there's like a little step there that you can probably just about see. So once again, they're marked with top, so that sits that way. And then we've got the oil control rings, which are a 3-ring design. So it has 2 rails and a controller ring per groove, basically. So I'm going to keep them in cylinder order. And then with my feeler gauges, I'm going to measure the gap. And then straight away there is a slight difference. These 3 are good. This one needs a little bit of opening up. Once again, I want to keep these 3 in order. So I'm going to put them on top of my toolbox. I'm going to fit the second rings. And straight away that groove there, or sorry, that gap there, looks like it's going to be a bit tight, that. So I think we're definitely going to have to open these second rings up a little bit. Right, I'm going to go and get my piston ring machine from over the other workshop. I'll take some measurements and then I'll show you how I carry on with these. So that's the bottom end on the 350 Chevy all done. So I actually wanted to film gapping the piston rings, but I forgot. So it's all been, it was stripped, it's all been through the acid, it's been bored, I've ground the crank, swapped the pistons and rods over, and put new core plugs and gallery bungs in it. My customer Graham come over and fitted new cam bearings. He wanted to do that job himself, and yeah, it turns over really nice. Everything's torqued up, and I've just put a little paint pen mark on it to know that it's torqued. So now I'm just waiting for Graham to come and collect it, and that's another engine done. I mean, we don't really get to do much American stuff here. It's normally all 4-cylinder stuff, so I've really enjoyed it. But since doing this, we've had another 350 Chevy come in for a rebore and some work, crank grind. We've done that and that's gone. And at the moment we've got a Ford engine and another 351 Windsor Ford to do as well. So We don't normally do American stuff, but we seem to be getting quite a bit of it, and I love it as well. I'd much prefer to be doing a bit of that, so it's all good. And that's that one finished. So thanks for watching this video, guys, and we will catch you on the next one. See you later.